Today what we're going to do is we're going to look at a couple of properties that help us to determine if triangles are congruent. So there's a few vocabulary words that I want to remind you about. Our first one is vertical angles, and I'm going to use what we learned about transformations in geometry to help us to prove congruent angles by virtue of vertical angles. Vertical angles are two angles that have been created by the intersection of two line segments. So notice that BE intersects with AD. And by doing so, it creates this almost like a V. That's how I remember vertical angles make those V's. Now, in geometry transformations, we learned that you can rotate angles. So notice that I have angle here. This is actually angle BCA. And if I rotate it, it maps identically to DCE. And so our two angles are congruent because I can map them to each other. Now notice that I can also, so that's a rotation, I can also do a reflection. If I pick it up and flip it, it also maps. So these are vertical angles, and I can say that they are congruent to each other. So in this case, triangle BCA or angle BCA is congruent to angle DCE. Now notice that I had to keep the C in the middle because that is the angle that we are saying is congruent. And notice I had to order matters here. So BCA is congruent to DCE. Now we can use this when we are trying to prove that angles are congruent. Even if it is not marked on your diagram, you know that vertical angles are congruent. Okay, our second one that we're going to look at is our reflexive property. When you were younger, you learned that A is always equal to A, like 1 is always equal to 1. So that's an idea that we now can apply to geometry. Reflexive property in geometry states that any shape is congruent to itself. So when I'm taking a look at my picture here, I notice that AD is congruent to DC. I know that because it's been marked with that little hashtag. I also notice that angle BDA is 90 degrees because of this 90-degree mark, and BDC is also 90 degrees. So I want to look at this, and I have to try to prove that these two triangles are congruent. So I have a side and I have an angle. I need another side in order to prove that this triangle, this ADB, is congruent to CDB. It would help if I knew that BD was congruent to itself. Well, reflexive property helps us with that. So again, I can even take my paper here and I can sketch BD, and notice that it's congruent to itself. Even if I flip it, it's still congruent to itself. So we have two triangles here, and if it helps, we can sketch them. So notice this triangle is congruent to this triangle because they share a side. Notice that this side is shared. Because it is shared, and because reflexive property says any shape is congruent to itself, I know that line segment BD is congruent to BD. So now I have my third side. I have a side, my sides are congruent, my angles are congruent, and now I can say that my BD is congruent to BD, therefore I can use side angle side. Okay, a third one that we're going to look at is our perpendicular bisector. A perpendicular bisector is a line that is perpendicular to another line. So BD is a perpendicular bisector of line AC. Since it is perpendicular, what that means is BD creates a perpendicular relationship. So in other words, these are now 90 degrees. Because perpendicular means it makes a 90-degree angle with whatever it intersects with. Now bisector, notice that bi means 2. Bisector means it splits AC into 2 equal parts. That means that this angle is now, this line segment, AD, is now congruent to DC. Because a perpendicular bisector, in this case, and let me go ahead and highlight it so you can see. BD is our perpendicular bisector. It bisects AC into 2 equal parts, and it creates 2 90-degree angles. So what that means is I now can prove that my angles are congruent and my 2 line segments. And if you remember from the last one, our reflexive property tells me that BD is congruent to itself. So now we can prove that this triangle is congruent to its neighbor, its other triangle. Thank you for listening.